Okay, let's talk about A on this problem here with your partner. 5% of his time was spent eating. Do I circle that? Do I not? Go. Look at Riley today. Either you move back there or you move up. Either one, right? Okay.
And it was like 47 or something. That's out of 48. Because it's 2 days. Saturday and Sunday.
Okay, so I was listening. I heard a few kids saying, hey, this is 2.5 over 48. Now, when you see 2.5 over 48, is this going to be a large decimal or a tiny decimal? Tiny. Because we know 48 over 48 is going to equal 1, right? That's a whole. So this is really small. So I do that division. And top dog would go in the dog house, so it would look like this. Bring out my decimal. And I'm going to have 0.05. And I believe it's a 2 after. So I go to the thousands place. Because of the 2, what do I do to the 5? Just leave it. It stays the same. So this is 0.05, which then equals 5% because I moved the decimal 2 places. That's how I get the 5%. So that is a true statement. 2.5 came from there. All right, B. Talk to your partner about B. Warren, move up here so you can talk to the girls.
Yeah, it's then 8 plus 2 8 hours.
So, this is great. A lot of comparisons. I love that a lot of you compared the 5% up here. You're like, hey, if 2.5 hours is only 5%, 10. How much bigger is 10 than 2.5?
5.
Almost. 4. 4 times bigger. So 4 times 5 would be 20%. So this here is somewhere around 20% compared to that. Not true. C. Clara.
C is a part comparison because, wait. Actually, no, it's not. There's not a 12 on there. It's adding up numbers from different hours.
So your question, so I can already see your question. You're like, wait a minute. 18 is sleeping. We get that. But there isn't a 12. But I can add up different amounts, Warren. I cannot add up different amounts to get 12. And so the question is if I take a few parts, can I consider a few parts still a part of the whole? Yeah. It's still a part of a whole. It's just combined for a few parts. So it doesn't have to be just one part and one part. And the reason why I say this is restaurants. Okay? So restaurants have menus. And on the menus, they have lots of different choices. So for instance, one of my friends, he is the founder and owner of Fireball. Okay? They have restaurants in Texas and Arizona and Colorado. And it's Asian. So they have they have noodles, they have rice dishes, they have meat dishes, and they have vegetarian dishes. Okay? So when they opened up their restaurant, they changed their menu a little bit as time went on because they looked at part-to-part comparisons. They compared vegetarian dishes, which were made up of a few dishes, right, to meat dishes, which was made up of a few dishes. It was still a part-to-part comparison. And they learned from that 3-to-1. 3-to-1 of their customers prefer having a meat dish versus a vegetarian dish. So because of that, what do you think their menu comprises of? 3-to-1 comparison of meat to vegetarian. It's smart, right? So those are made of small parts, but it was still a part-to-part comparison, made of many different dishes. Does that make sense? So yes, you can have this, and then that 18 is sleeping. Wow, that'd be a lot of hours of eating. That was eating. Whew. And then you can make it with internet, sports, and homework. You could also do it with other and eating to get the 12, the other part. So this bottom part could be made of 3 parts up here, or it could be made of 2 parts. But what I want you to understand is what Claire was thinking. Yes, a part can be made of a few parts. Ben?
So like on the 8 to 12, like since you can like reduce it to like an improper fraction.
Well, I wouldn't want to reduce it, but I could reduce this to be a 3-to-2 comparison. Okay?
So like if you did reduce it, like would it equal like something else, like a whole or something?
You can't really do that with this, because this is why. These numbers aren't numbers. They're actually a relationship. This is a relationship between eating, and let's say this down here is other and, not eating, is it? Sorry. Sleeping. Goodness gracious. And then this is other and eating. So I wouldn't turn this into anything other, because those numbers, they're not comparing numbers. We're comparing categories. So you wouldn't change it into an improper fraction or a mixed number or anything like that. He did his homework 4% of the time. Talk to your partner. Go, 1 minute. Max, come on. Head up. Head up. I know you don't. You've been gone for a week. Max, go back there, so we can help you out, so we can give you the support that you need.
It's not this. I'm willing to go back and do the lesson. I don't know what.
I know. Come on. Okay, what do you think here? Taya, 4%? Yes. Explain why, Taya. So you said, hey, this is 5%, and that's 2.5 hours. This is 4%, and this is only 2 hours. So still, this is 2 out of 48, right? So I love your logic. I love your mathematical thinking. But what would I tell you to do? Do the math. Because the thinking is fantastic. But remember, we're in a place now where your logic and your thinking are greatly appreciated. I love your math brains. But you must do the work. Because all that logic and thinking, all it needs to do is support the work. That's it. That's all we're looking for. But you need to do the work. Because remember, seventh grade math is getting more difficult where you just can't look and be like, oh, that's what it is. Okay, guessing is not great. I would argue with that, and I would say that 99 point... No, just kidding. Questions about this? No? What's a big idea? What's something you're going to take away from this here today? Go talk to your partner. One thing that you're going to take away and remember? Do the math. Okay, so tomorrow, I'm not here tomorrow. I'm not here Wednesday. I'm at a math conference. I get to geek out with other math geeks. Sweet. Love it. No, I'm not the only geek. It's a room full of geeks. It's great. So, pretty excited about that. So I'll be gone. Miss Riley is here. And I think I had this conversation with you when I was gone with my father about you have an opportunity. It's a pretty cool opportunity. And like one of the things my dad always told me, never turn your back on opportunity. Because you just never know. You don't know if Miss Riley's all of a sudden a CEO of a company and you're applying for a job and you can be like, yeah, remember that? I was in that seventh grade math class. That goes a long way. You broke down on the side of the highway. She drives by. She's going to help you out. If you're a pill, she's going to keep driving. I guarantee it. She'd be like, hey! Okay? But if you come across as being a respectful, considerate kid, which all of you are, I know that. She doesn't. Okay? You can make that impression. Ben.
Is she one of the folks we've had so far?
I don't think you've had Miss Riley. Yes, you would have had her in fitness help. Yes. She is she's great at math. That's why I personally requested her. I worked with her up in Buena Vista. Yeah.
Wait, is she the one with like blonde hair that substituted for science one?
Nope. I don't think she substituted for science.
She substituted for science.
Oh, she was Miss Agetz one day, wasn't she? So take that opportunity. Grades are all done. They're in. Boom. That's your grade. This is a cool problem, and I didn't have this problem much last year, but I've already had it a few times this year, which I like. But I want you to understand: if you take a test for the second time and you did not well on it, and you crush it the second time, it's hard for me to give you an A because it's the second time. So there's a few of you in here who took it for the second time, and you did awesome. My suggestion, if you want that A, make sure you're prepared the first time. So I scaled you down to a 29 out of 32, which is a 90. So yeah, you're not getting a 96 or a 97, but you're getting a 90. And that was way better than what you got before. So I appreciate the hard work the second time. My suggestion, if you want that A, make sure you're prepared the first time. Okay, that's not fair for the kids who studied and prepared the first time. For you to be like, yeah, I got an A too. So Friday school, 9:30, 11:30 this week. If you're falling behind this week, I know Ben, you missed the whole week, and Max missed more than that. Okay, good opportunity to catch up. And Miss Harris is here again. We're talking about proportional relationships. What's a proportion? Yeah. It's a ratio. And if I say a proportional, what is that?
Part to part.
Could be. What else could it be? Part to whole. And if it's in a relationship, that means it's compared to something else. Okay? So it's basically what we've been working on. These ratios, something to something else, could equal maybe something to something else. Okay. With Taya and with mine. Now listen, with this, everybody is participating. You're not over there just like, look, and if you have a question or you disagree, I want you to grill them. Make them think it through. Make yourself think it through. And the rest of you need to listen to that conversation. So this half over here with Maya, this half over here with Taya. And then tomorrow, Lulu and Riley just volunteered. It's fantastic from you two. He's like, wait a minute. I don't remember volunteering. I just heard you call my name, but I'll do it.
Yeah.
You do your homework every day. Huh? No, you don't get that opportunity. All right, Rouse, you're in the hot seat. Oh, wait, no. Who is it? Maya's in the hot seat. Right, come on. There you go. Get up there, girl.
Oh, okay.
You guys get over here. Get your homework out. Defend it. You need to do it.
What?
Okay, well, finish it. You need to work on it. Here, don't copy down the answer. Do the work. Here. Do the work. That's not going to help you. It'll help you get it done, but not really know what to do. Huh?
There is a chance I made a mistake, so. Actually, there's a very good chance I made a mistake.
No, we're on investigate.
What?
We're on investigate.
What did I make?
On the B, it's just 3 to 2 since
I
it
think it
started
was
off
20
with the part to whole ratio of
It's 12 and 13.
3 fish with solid water
In the
to
first
the whole
investigation,
thing.
not 2.
So then it would be 3 to 2. So it started off as 3 to 5, and it was water to the mix. And so then 3 plus 2 equals 5. So then it would just be 3 to 2.
Because they want a concentrate to water ratio. Boom. And what do you have? Concentrate to
Whole.
mix ratio. Does that make sense, Maya?
Concentrate to mix to.
This is, think about it. This is what she's forgetting. This is water. This is mix. This is concentrate. This is mix. So they want to concentrate to water. Now you labeled them. It would be a 2 to 3. Does that make sense? Mm-hmm. Because you're going from a part to whole with the 3 to 5 because it says mix to water, right? And so now you have to be like, well, if the water's 3, the concentrate must be 2 because it's 5 pieces total.
Yeah. That makes sense. But
Oh, she has.
it's following me.
Okay. All right. So the first one is 60 to 40%, right? Yep. Because that would be 100%, so it would be 60%, so it would be 40%.
Plus 60 plus 40.
That is
And I
what they
corrected
need.
that.
But what do those numbers
C.
mean? Because I just said it over there. I'm like,
It is not possible because they do not tell you. Yeah, I just said they don't have it only tells you the difference.
Yeah, I just said it's not possible because they don't tell you any of the parts or the whole, so there's nothing for you to make a ratio out of.
So they said 60% is
Because
concentrate.
in a difference of 4, it could be
So they're
anything.
asking-
It could be
they're
50 to
asking
54
for-
or
The whole
like.
thing about it is that they want a
Did I do
concentrate
something weird?
Yeah. So
water
on the
ratio.
13A.
Okay?
Oh no.
So if
Never
they
mind.
say,
The first one I said part to part, the second one I
60% is
said part to whole, and then the
concentrate.
third one I said part
What's
to
the other
whole.
part?
Oh, I said that too, but I recorded it wrong, of course.
So
But yeah, that is part whole.
you can do either one.
This thing is not working.
Right? That's an equivalent ratio.
Okay,
you could
then.
do 6 to 4. You could do 12 to 8, right? All those are right.
Here it is.
So what about this one though?
This
Let's
is a
talk about
good
these.
marker.
They have the same question that we do. So I might be It's asking for this. Still asking for that. Talk.
There we go.
You guys are done?
Yeah.
Pretty much? Any other? No?
Yeah, I
All
recorded
right.
it wrong.
Hand it over, girl.
Yay.
You love this. Yeah, you do, Maya.
Follows me around and records my every move.
I know. It's really good, isn't it? It's good.
Because I was in there a bunch. It was pointing.
Okay, ready? We're gonna pause. I like everything over here except there's one piece. So, you guys, return to your seats. We're gonna go over it. I want to talk to you about 12b. This is the way it's worded is really. So, first of all, I'm going to go back to 12 and just read it. If possible, write each comparison of concentrate to water as a ratio. That means this. Concentrate to water. That is my ratio I'm looking to make. So, the fraction of the mix that is water is 3 to 5. So if it is 3 to 5, what's 3? Yeah, what? The part, which is water. And what's the 5? The mix. All right. But they don't want this. They want that. So Jacob, this is a 3 to 5 ratio of water to mix. So what's the concentrate to water ratio?
A 2 to 3.
2 to 3. Because how'd you get the 2? And it's the part that's missing here, right? If this is a part to whole, the other part to whole is a 2 to 5. So, concentrate, water.
Oh boy.
And then some people didn't understand question C, partially because it's so obvious that it's like difficult. You know how when that happens, it's like obvious but difficult? Yeah, it's too obvious because this is the difference between the amount of concentrate and water. Well, what does the word difference mean, Axel?
Like the amount, I don't know, the difference.
Mathematically, difference.
Oh.
Then? Subtraction. The answer of a subtraction problem. Did you get that, or were you thinking of like difference as in like?
Well, I understood that. I don't know. I just couldn't explain.
So this is what they're asking. I know that concentrate minus water is 4 cups. So how could I write a concentrate to water ratio? Yeah.
Oh wait. 1 to 5.
Not 1 to 5. Other way around. 5 to 1. There's one answer. Michaela, give me another one. So that's concentrate. That's water. That works because 5 minus 1? 4. Well, 4 minus 1, is that going to give me 4? 6 to 2. 6 to 2 would. 6 concentrate to 2 water. So you could have written, I mean, there's so many answers to that one. But it's almost one of those that's so obvious that it's kind of hard because you're like, what? I remember I read so many of them that you're like, but I don't know the total. But you didn't need to. It wasn't asking for, it's just asking for an example of that shown in a part-to-part relationship.
Well, I just don't understand that, like, it's 5 cups of concentrate for 1 cup.
Yeah. So that's a really strong juice. That'd be like, man, woo! Zippity! If it's a Welch's, man, you're buzzing. Like, that's like going to give you a sugar high for sure. Like, yeah, and you burn hard, crash and burn hard. All right. Tomorrow I got Riley and Lulu. You guys are up tomorrow. Okay. All right, here we go. Get out your notes for today. We're doing a little different today. Trying to mix it up. I like our routine. We're sticking to it. It's like a routine with a spin. So instead of doing the engagement piece right off, I want you to do this. Read page 41. Then, James, solve problem A with your partner. A's on page 42. So read, I want you to tackle this, and I want you to tackle it. I want you to do 2 things. Number 1, and this is how I want us to get better at this. First thing I want us to do, write down. What do you think you should write down? Everything you know. Write down what you know. When you're done with that, go to 2, and then what do I solve for? And then 3, do the math.
Can we just do A and
I love logic. I do the math.
do we solve the problem like right here?
Yeah, right on that or on the back like we always do. All right? Liam, go back and work with Warren. All right? Looks like we're good. All right. So, talk about your processes, okay?
Or strategies.
Okay. Yeah, sure. 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 Yeah.
You also need.
Campers at each table share the pizzas equally.
I'm ready.
The campers at each table share the pizza equally. Does a person sitting at a small table get the same amount of pizza as a person sitting at a large table? Explain your reasoning. Well, there's what we know is there's 8 people at the small table, and 10 people. Yes, I was getting there. 10 people at the large table, and there's 4 pizzas at the large table, and 3 at the small table. So, what you would do is you would do the division, like divide it up.
Couldn't you do it like a ratio?
Well,
Like, because here it's like 3 to 8. And then
Sure.
on the big table it's 4 to 10.
yes, you could do it as ratio, which we can do right now. You could make it into a ratio or do division or both. Well, the division is skipping the ratio, so that shouldn't be a problem. Because it's just doing
Do the division.
3 divided by 8.
Division then.
You just do 3 divided by 8 for the smaller table.
Small.
Sorry. So, basically, have you ever
So 3 divided by 8.
Yeah, so small table
3's in the big house and then the dog house.
is 3.
So 8 goes into 3. 0 times. And then 0 times 8 equals 0. And then 3 goes into 8. 2 times and 2 times 8 is 2 times 8. 4, 16.
8, 16, 24, 16.
24. Oh, what is it?
Just that can be like 30 and 8, 16, 24. That's 3. Not 2.
Oh.
Because 2 would only be 16.
Wait, so it would be 0.24, right?
No. The 2 would be a 3.
The 2.
Because 8 times 3 is 24. And then you go off of there. .3.
Wait a minute. So 3 is not in the doghouse? No, 3 is in the doghouse.
So that's the closest you can get. So 0.37. That's all I know for now.
2 minus 6 is 14. 14 goes into 14.
I already figured it out.
1 times 8. Wait, you already figured it out?
Should be the equation. It's 0.375, which can be rounded up to 0.38. So each person gets 0.38 of the pizza. Each person gets 38% of the pizza. Wait.
Oh,
No.
yeah.
Would that be right?
Because there's 3 pieces.
Each person gets 38% of the pizza. Yes.
Hold on. We're going to look at it over here. All right. So if you guys could look over here, I'm writing down what we know. And some of you might not have seen this. So, small table. Yeah. 3 pizzas. 24 slices. 8 people. Do we know anything else? Did I miss anything there? Large table. 4 pizzas. 32 slices. 10 people. What do they want me to find? Yeah.
If the people at the small table get the same amount.
So they're wondering if these are equal, right? They're basically asking me, now, equal in what sense, though? How much pizza each person gets? So, do I do pizzas to people? Slices to people? What do I do? Jackie?
I'm thinking you do slices to people because it's like not like.
I don't take a pizza and just start right? I eat with a slice.
Yeah.
Right? Whether I fold it or accordion fold it or flip fold it, doesn't matter. Some of us use fork and knife. You look like a fork and knife girl. No, you're accordion fold shove. Yeah. Not quite that extreme. All right. So Jackie just said she thinks we need to find slices per person. Does that make sense? Or does do people to slices? No. That doesn't make sense, right? We don't want to know people that.
I'm doing people to pizzas.
I didn't even think of it that way. People to slices. You're assuming the slices are eating the people. Interesting. Wow. Okay. All right. But slices to people. That makes sense. Do we have the information to figure this out?
Yes.
Yeah. Look, slices people. So basically, small table is 24 over 8. Well, darn, that's easy. 3. What does that 3 mean? You get 3 slices per person. Okay? Unless Axel shows up and licks the whole pizza. And he ruins it for everybody.
He seems like that kind of guy.
Yeah. All right, tell me about it. All right. Next, we got 32 over 10. Well, that's easy math to do too. 3.2 slices. So people at the larger table get more pizza, but what's going to happen at the larger table?
They're going to have to divide up the pizza.
They're going to have to all of a sudden there's going to be a piece left or 2 pieces left. And everyone's going to be who's going to be the polite one to be no, I'm hungry, but I'm not going to eat it. And who's the overbearing one to be yeah, I'll take both pieces since they're left over. Then Ben's that's me. I'm pulling the 2 pieces of pie to me. Right. They're just sitting there. They're going to go to waste. All right. Go to B. Now, guys, with B, listen. You're going to I want you to set up proportions. We don't have very long. We have 3 minutes. Proportions. Here we go. Come on. Go.
She uses 2 ratios, 8 to 3, and 4 Wait, so the get more pizza. And it says, do you agree with Luna's reasoning? Explain. Alright, so we're going to sample 1 right there. And 2.
What percent?
whether a person has a large table gets more pizza, right? Like, okay, so there's so she uses the ratio. I guess she uses the ratio 8 to 3 because 8 people, 3 pizzas, and 10 people, 4 pizzas.
So wings.
So I'm guessing this is people.
What's up, Lulu? Going guys on B?
And then it's a difference of 10 or 6.
Chill.
Which is true.
Relaxing.
So we're going to do 8 to 3.
I wrote,
5.
I do not agree because
The large table has more people.
people provide
What the small people will get more people.
Guys, come on.
This is the bigger table.
No, Selena's wrong. Well, just because it's a difference in that doesn't mean that you can't go into further detail. I mean, just because it's
Talk to Ben.
did
I don't know if I should do 10 and 4. Like, that doesn't really have to do with the people at the small, like whether the people at the small table will get more people.
Wait, no.
Like, what's wrong with her thinking?
Yeah.
Or what's right with her thinking?
She did pizzas
What's
with
right with
people
her thinking
instead
is
of
like 10 and
slices.
4 because
It doesn't
there's
really
10
matter.
people.
Well, it kind of does.
It's also the percentage.
Yes, you can do a percent.
Is this math right here, like 10 and 4. And then that's it. Like, I'm trying to do that one, you would see that.
Okay, we will come back and tackle B. Today's a short day. Put away your math. Goes in your learning tab as always. For the kids that weren't here, remember you find your stuff over in the folders with the correct date. All right. So, get your planners out. Now, logic is great. I'm telling you, I love the mathematical thinking that you guys do. But what I'm going to ask you to do on this problem is try to set it up as a ratio, equivalent ratio with an unknown. And you solve for the unknown. Homework. 1, 2, and 3. 1 and 2 are just single, and 3 I think is A and B if I remember right. It's on page 51. So we're talking about this proportions, right? That I can decide if two quantities are in a proportional relationship, meaning they're equal to each other. This is a perfect example. I have one quantity which you already know. Come on. What do you know, Jacob? Hmm? How many pizzas should the camp order? What else do we know? I got 2 things. I know one more thing. Yeah?
3 pizzas per or 160
160 campers.
Yes.
So we can change that people to campers, right? So what's the question? Leanne, what do they want me to find? How many pizzas for the campers? So how many is my unknown, right? How many pizzas for 160? So this is pizza. This is camper.
This is a reminder to the boys basketball players. Your PE turn-in for your uniforms for basketball is on Wednesday. Directly after that, you will walk to Wallgangers for your party. But you need to make sure your uniforms are here Wednesday and turn them in after school. Thank you.
Okay, so we have X pizza over 160 camper. Do I have a ratio that I already know that matches that ratio? Yeah.
3/8.
3/8. Pizza, camper, it matches perfect. Do we see a scale factor from the known to known? What is it? 20. So that means I'm going the same direction up top. So scale factor is the same because they're equivalent. So this is 20. 20 times 3. X equals 60. And what does that 60 represent, Streeter? It represents pizzas. Have a good afternoon.